three. I mean, in reality, it's three, but we in a world where.
What are you talking about?
First one. I don't know.
Scatter one.
It could be one or three. It's probably one. That's in a perfect world, Declan. We ain't in a perfect world. For example, I am 5'6". Now he's about the same as Jake. Jake is 6 feet tall. And he's about the same as Jake.
Fair enough.
Sorry.
All right, so yeah, I mean you can make a case for a lot of these possibilities. So just to kind of reconcile all this, a scatter plot, just by definition, is the relationship between x and y in graphical form. Or I'll just say graph form. All right. So basically ordered pairs. All right. So you have two variables. One is x, the other is y. So it's a question of, well, what's the relationship? All right. So you have your three scatter plots. The first one, if one of these, you have your three scatter plots. And then your first scenario, if one of these scatter plots represents a relationship between height and weight for 8 adults, which scatter plot do you think it is and why? And that's a reasonable assumption, because you would say, well, it could be really all over the place, all right? But if we assume that A, B, and C each correspond to a unique graph, then it's kind of in our best interest to read through all of them before we make a decision, all right? If one of these scatter plots represents a relationship between height and SAT math scores for 8 high school seniors, which scatter plot do you think it is and why? If one of these scatter plots represent the relationship between the weight of a car and its fuel efficiency for 8 cars, which scatter plot do you think it is and why? All right, so let's start with the most obvious one, or the one that you think would be the most obvious one. A, B, or C, which one's the most obvious one?
A. B. Oh yeah, B.
For A?
All right, so I guess I have the advantage of like life experience a little bit.
C.
Yeah, only because I mean I fill up my little Honda Civic, and yeah, I fit into a little Honda Civic. They're roomier than you might think. I never spend more than $30 to fill up that thing, and I get a solid 300 miles for that tank.
Yeah, but smart cars.
Oh yeah, smart cars, or the electric cars, things like that. You know, you don't pay for any gas. Now, Chevy Tahoe. Yeah? Yeah, it does haul. So does my little Civic once I turn the economy mode off. So, and also, it does come down to your ability to drive it, and, you know, I'm legit when it comes to that. But anyway, I decide whether or not I'm going to get gas based on, first off, whether or not there's a ton of cars at the gas station. If all the pumps are filled, you know, like with cars, then I'm probably not going to go. But if all the cars there are little like little tiny Toyota Corollas, then I'll pull into the gas station because they're going to be done pretty quickly. But if one of them is like an Escalade and another is a Tahoe, and then you got a GMC Yukon, and then you got like, I don't know, what's another one? Give me a big one.
Lincoln.
A Ram truck.
A Lincoln Navigator, right? Or a Ram truck. Just staying away from anything that's diesel. All right. Am I going to pull into that gas station?
No.
No. Why?
It's going to take a long time.
It's going to take a while. All right. Has anybody actually filled up a tank for one of those big cars?
No.
No?
I fill up my brother's little car.
You fill up the little car, so you're in the same boat with it, like a little bit less than $30, maybe a little bit more than $30.
Yeah, definitely got a 2001 Honda Civic.
Nice, nice. And that's the other thing about Honda Civics, they last forever. Well, that's the only reason why they would not last forever. So, yeah, you're talking like $70, $80, maybe $90. If you let it go down to like fumes, when you got to pump the gas. And now, here's the thing. You think, like, you put more gas in it, you get more mileage. Now, when I fill up my little Honda Civic, I get around 300 miles. Now, when somebody fills up their ginormous GMC Yukon with $80 to $90 worth of gas, how many miles do you think they're getting?
300.
200 to 300 miles, all right? So, which car has better fuel economy? The little Honda Civic, all right? So, in that case, the size relationship, I think, would be obvious, all right? So, as the size of the car increases, and as the size of the car increases, the weight increases, the fuel economy or fuel efficiency is going to decrease, all right? You're talking, for my little Honda Civic, you're talking to 30 to 35 miles per gallon, depending on how you drive. If you're talking a GMC Yukon, you're talking 15 miles per gallon, all right, on average, all right? So C would be plot 2, because as weight increases, more power is required to move the car. All right. I go to physical therapy once, twice a week, and one of the things that they make me do, because I have spinal issues, I have to actually decompress my spine, so they make me hang from a pipe. You know, like, I actually have to hold on to it, I grip it, and then I drop. And then I have to hold on as long as I can, and it decompresses the spine. My spine feels great afterwards. I mean, I get calluses and blisters all over my hands. One time I forgot to take my ring off, so that tore up my ring finger, that sucked. But the reason I'm bringing this up is because the physical therapist was like, "Come on, man, you can do it." I'm like, "Shut up." Because he's this little tiny guy. He's like, "I can do it for like 2 minutes." I'm like, "I can do it for 30 seconds. Now, I promise you that if I was your weight, I could probably do it for like an hour. Right? Because I have the strength of a person that's like this big. You know what I'm saying? Like, if I actually have to physically move this body down the hall. All right, so my legs are powerful. You know what I'm saying? Like, when I get up out of bed, I have to push myself up. My arms are powerful. So if you take this strength and put it on like a 150-pound frame, like, I mean, I'd be a beast. Like, so this guy's like, "I could do it for 2 minutes." I'm like, "Yeah, oh, okay." So I get an idea. Why don't you strap a 150-pound weight to yourself and then do it? See how long you can do it, pal. Right? So the size relationship does come into play. All right? So the efficiency, it does go down. All right? So these are the contextual things that you have to consider as you go on. All right? Anyway, and that's why, like, professional athletes, which I am not one, I appreciate that. But they have the high caloric intake. You know, like, I call it the Michael Phelps diet. You know, like the... Yes, they consume gallons of chlorine on a daily basis. Actually, as it turns out, that might be the case. Like, how many calories are you supposed to have on a daily basis? 2 to 3,000, like 3,000 on the high end, right? You know how many he has?
2.
10 to 15,000, or had when he was extremely active. So that's because he needed more fuel, all right? So he's more like a GMC Yukon, all right? So now we've narrowed it down. So 2 is out. Now let's look at B. Does your, because we're looking at height and SAT math score, does your height have an impact on your SAT math score, do you think?
No.
Well, it depends on where you're standing. I'm really tall. And I am really, really good at math. Yeah, but there are people of all varying sizes that are really good at math and really not so good at math. So this would correspond with Scatterplot 3, because And I'll write it as a question. What would height have to do with math ability?
Would like a regent's later respond to that question? Or would height? Seems like you're kind of not confident about your answer.
Yeah, this is for note-taking purposes. I would not write that on the regents. Elaborate a little bit more. Actually, there are studies that actually evaluate a person's height and their ability to be successful in class, like in an actual academic classroom. And that's because people who have who are taller, like these desks and chairs are all the same size roughly, right? I mean, there's minor fluctuations. I mean, as you get older, you're gonna see, like, you get into like junior, senior year, you're gonna see a lot more jockeying around the classroom for particular desks and chairs. Like, a student will come in and be like, oh man, how am I supposed to fit into this thing? Right, so there's an element of comfort. But then the hunch-overness, like if you're a taller person, you have to hunch over more to get there, and it puts a lot of strain on your lower back. All right, if you're a shorter person, now you gotta reach up, it puts a lot of strain on your upper back. All right, so, size could have an impact, and these are studies that have actually happened. And actually, as you saw yesterday, because a lot of that stuff ties into what we were talking about, especially the one with the NYU doctor.
No.
Were you not here?
Of course I wasn't here.
Oh, okay.
I wasn't well.
Oh, all right. Well, you missed a good one, because it tied in very nicely with what we're doing in class. And he was really discussing, I mean, he used a lot of terminology that we would use in this unit. I had no idea he was presenting, but then it turned out we got lucky. It turned out that he was presenting stuff that directly related to this. But you can see, if you were there for that presentation, that they're looking at a lot of different things and seeing how they relate to one another, right? So, I mean, the idea that a PET scanner has to be silent because if it makes any noise, that noise could impact the brain. And if it impacts the brain, it would cause activity in the brain, which would skew the results when trying to make a determination of what a causal relationship would be. Because they're looking for cause and effect. They're trying to eliminate every other variable except the one they're testing and the outcome that they're looking for. All right, causal relationships come up in this unit, and also, determining relationships between different variables just in general. All right, so we've eliminated 2 of the plots, so we're down to plot 1. So the one thing you would not want to write on the regents is it's plot 1, because that's the only one left. Plot 1. Let me just write that as a number 1, because generally larger people weigh more. Well, that's obvious. Taller people weigh more. All right, not always a truth. My nephew is, geez, I should know this. He's a little over a year old. He is a shade less in weight than my 9-year-old son.
What?
Yeah. He's very dense though. He's not like obese by any stretch of the imagination. The doctors say that he's fine. It's just his bone density is a lot larger than a lot of other people. So he's like unbreakable, I guess. So like you can run through a brick wall and have no effect on it. But I mean, it was one of those, like, if you were to pick up a stone, like a statue of like a toddler, like if they made a statue of a toddler, that's what he feels like when you pick him up. Like, I was like, oh, cute little baby, I'll pick him up. Oh, jeez.
You won't be able to swim.
And it's not rotund in any stretch of the imagination. But But yeah, he packs a wallop, so. You know. So there are exceptions to these rules, but generally, you know, what do they say? The bigger you are, the harder you fall. You know, so that's what that question is. All right, two variables can have a strong correlation, but might not have a causal relationship. Yeah. Actually, a casual relationship would be the opposite of causal.
Yeah.
All right, if that's actually a term, we can make it one. But if we were to read that as casual, we would say that, yeah, there's probably some kind of relationship, but there's nothing more than, you know, as one increases, the other increases. Well, what we're looking for is a causal relationship, which is talking about cause and effect. All right, that's where if you're actually doing a clinical study, and this is something you get into as the years goes on, like AP Stats, even Algebra 2, you do a little bit, but you're looking for one variable to cause a change in the other. All right, mathematically, that's very hard to justify, but in terms of actually an experiment, if you follow the right procedures, it's not terrible. The problem is you have to follow those procedures very closely. I had a friend who was doing a master's thesis obviously in college. And so he was doing, I want to say it was autism in the elementary age group. And he went around, interviewed families, collected all of his data, wrote up his study, analyzed the statistics, drew some conclusions, went to defend it. Before he even got in front of the panel to defend his paper, and by the way, that's a thing. The panel is like a group of people that will ask you questions about it. So like when you present in this class, I'm the panel, and maybe some other students. But when you get to college, it's like a group of professors who are very intimidating to look at, right? And so they're judging you. You know, if you don't convince them, you don't get the grade, right? And by not getting the grade, you don't get a grade. You have to take it back to scratch. He didn't even get that far because there was a flaw in his data analysis, data collection, and because of that, he could not establish causality, and so basically a year and a half of his life was thrown down the tubes. He had to start all over, right? So you know, you could be in a position like that, but even more importantly, you know, if you actually are aware of these things, you listen to the news, you look online. You can see instances where drugs are being recalled, you know, like, oh, don't take this medicine, it'll kill you. And you're like, how did they miss that? Because in the trials, the lab testing, there was a flaw in their analysis, data collection, and then how they analyze the data. And because of that, they put people's lives at risk. Right? And that happens with technology, you know, like there was the whole wave of Samsung Galaxy phones that were blown up in people's pockets.
Yeah.
Third-degree burns, yeah, that I imagine that was fun, right? So, yeah, they missed something, obviously. And then, of course, if you were here for the that same presentation I was talking about a few minutes ago, cadmium in vape pens.
Oh my God.
Like, how'd they miss that? That's a toxic metal. Right, it's going to settle in your kidneys.
I know, isn't that disgusting?
A nanoparticle settling in your kidneys and never leaving for the rest of your life.
Kidney failure is great.
Isn't that absolutely disgusting?
My wife's mother worked in dialysis.
Absolutely horrifying.
That's where your kidneys stop working, and they have to put you on a machine to actually clean out your system for you.
That's disgusting.
So that's what a vape pen will do to you. Apparently.
Yes.
But they were marketing that as being safer than actually smoking a cigarette.
Which isn't true.
Which apparently is not true. Or not as true as they were kind of leading you to believe. But these causal relationships are hugely important. Right? If you don't attend to causality, you're failing not only yourself, but society, really, depending on what you're working on. Right? So in each of the following scenarios, two variables have a strong correlation. Determine if there exists a causal relationship between the two variables. All right? And if so, which caused the other? A person's weight loss and the number of hours a person spends in the gym per week. Causal, not causal?
Causal.
Generally causal.
Causal.
We could make the claim that that's causal.
Yeah, but
Well, that's what we call a lurking variable.
It's working. Wait, so it's not casual?
What, your husband? I would be letting myself down if I didn't.
I mean, you can
Perpetuity is not myself. I would, like,
you can talk to doctors. You can read online. Anytime they talk about weight loss, you have like the fad diet that's out there. That's the one that's like, all right, well, eat this type of food, take this supplement, drink like 13 gallons of water with a pinch of lemon juice in it, you know, like all that stuff. Apple cider vinegar, you know, all that stuff. That's all well and good. Studies have shown that the number one way to lose weight is exercise. Gotta go to the gym. Well, you guys have the advantage. You have to go to the gym, but then you often don't realize that until it's too late, and then you don't have to go to the gym anymore, and then life takes hold of you and you see what happens. The number of ice cream cones sold, and then number of people who go swimming.
that has nothing to do
No,
with each other.
not causal.
No. Not oh, I said casual.
It's casual.
All right, so not causal. We only had to determine if it was, so we don't need to explain it.
Oh.
All right, but that being said, we could say that there might be a relationship between those two variables, right? Because if you're going swimming, maybe you're at the beach. If you're at the beach, maybe there's an ice cream stand, all right? Or maybe you're at a park and there's an ice cream truck or something like that, all right? Or the pool, yeah, the park with the pool, you know?
Yeah.
They often have an ice cream truck or an ice cream stand there. So you might be, I mean, if you're at one of those, you know, summertime event, you're probably seeing lots of people with ice cream. That doesn't mean that they went swimming because they had ice cream. They felt this compulsion to go, or the other way around. Man, I worked up an appetite specifically for ice cream. All right.
Yeah.
The next page we talk about correlation. So correlation is a mathematical value that indicates the strength of a relationship between two variables. We don't even look for causality unless we have a strong correlation coefficient. Generally speaking, the closer the R value is to 1, the stronger the relationship, or -1. All right? So the R value indicates strength of the relationship between two variables. The closer it is to 1 or -1, the stronger it is. All right. Should I have? Oh, that got away from me. All right. Oh, look at that handwriting. So our R value indicates the strength of the relationship between two variables. The closer it is to ±1, the stronger the relationship is. If it's 0, that means that there's absolutely no relationship between the two variables. That means no matter what x is, y will never change. All right. The only way that actually happens is if there's a horizontal line. All right. So no correlation. It's all written down for you? Oh, wow.
Yeah.
Oh, cool. I don't know why it's not written down on mine.
That's weird.
Whatever. Okay, so you have it then.
Come on, wait, Mr. Ken, if I get one, can I like give it to someone?
Yeah, that's what I told you last time.
Oh, for God. Yeah. Be generous. No, I give the rest. I don't need your extra.
Okay, so you got your perfect positive, perfect
Wait until the
negative,
test comes.
declining levels of strength as you go left to right, top to bottom. All right, so perfect, strong, moderate, weak, none, weak in the negative direction, moderate, strong, perfect in the negative direction. All right. So the ones on the bottom are unclassified for you, right? All right. So what would the R value be for number 3? R equals 1. All right. What interval do you think would apply to number 4? Strong positive. So that's from what to what?
No, Haley.
We're talking about 0.7 to 1, right? So R is bigger than 0.7 and less than 1. Just anywhere in that interval. Now these are like Regents rules. It's really kind of annoying that they make for the Regents for some reason. I have no idea why. Because like I've taught college level and AP statistics for almost 20 years. These are not rules. The rule is the closer it is to 1 or -1, the closer it is to perfection. And that's it. There are no benchmarks. Because once you start moving sufficiently away from 1, then you dismiss it. It's not like in the real world, you're like, okay, so I got a weak positive correlation. What do I want to do with that? You do nothing with it. Because if there's a weak positive correlation, it means there's no correlation. There's no meaningful correlation. All right. So the next one would be
0.3. I don't know.
the 0.7. So for some reason you need to know this. I don't know why. What about the one after that?
0. Oh yeah,
Negative 0.7. Oh, what would you say? -1? Sorry.
You need to put the point 0.
I'm confused.
As you always are.
No.
I don't know, Henry.
I left off the negative there. All right, so then negative 0.7 to negative 0.3. And then we would say 0, right? All right.
Yeah.
Oh, actually, no. Sorry. This one would be in the interval, anywhere in the interval of -3 to +3. All right, because the only way it's equal is 0, and here's something for someone. Make it a number 9. That would be R equals 0. That's the only way that happens.
That's 2. That's 2 in one day.
All right, because that means
One stone.
that no matter what happens with the X value, there will be no change in Y. You look at a data set, for example, like number 6. You say, okay, yeah, I can fit a line to that, I guess, but would I be better off fitting some kind of polynomial function to it? All right, or maybe, well, I guess maybe not like an absolute or anything like that, but maybe you can get an exponential function through it. All right, so when you're studying data values, when you're